Good morning, students of class 12. Well, I have started organic chemistry with haloalkanes and haloarenes. First, we are going to discuss the methods of preparation. Number one, from alcohols by the action of halogen acids. Ethanol CH3CH2OH, which is a 1 degree alcohol. 1 degree alcohol means primary alcohol. So ethanol reacts with hydrogen chloride in the presence of anhydrous ZnCl2 to form ethyl chloride and H2O. In the second reaction, we are using a secondary alcohol, that is a 2 degree alcohol. I have taken propan-2-ol, which is a 2 degree alcohol. It reacts with gaseous hydrogen chloride, again in the presence of anhydrous ZnCl2 to form 2-chloropropane and H2O. Now let me tell you the function of anhydrous ZnCl2. The purpose of anhydrous ZnCl2 is to help in the splitting of the CO bond. ZnCl2 is a Lewis acid and therefore it readily coordinates with the oxygen atom of the alcohols. As a result, the CO bond weakens and finally breaks to form carbocation. The carbocation then readily reacts with chloride ion to form chloroalkanes. Alright students, now I have used tertiary butyl alcohol. Yes, it is called tertiary butyl alcohol, which is a 3 degree alcohol. And the IUPAC name of tertiary butyl alcohol is 2-methyl-propan-2-ol. So 2-methyl-propan-2-ol reacts with gaseous hydrogen chloride at room temperature. Okay, we are not using anhydrous zinc chloride over here. So tertiary butyl alcohol reacts with gaseous hydrogen chloride to form 2-chloro-2-methyl-propane. Now children, I would request you to take notice of this. We are not using anhydrous zinc chloride over here. Why? Because tertiary alcohols are very reactive and therefore they readily react with concentrated HCl even in the absence of zinc chloride at room temperature. Okay students, please pay attention. Ethanol reacts with hydrogen bromide in the presence of concentrated sulfuric acid to form bromoethane and H2O. In the next reaction, ethanol reacts with hydrogen iodide to form iodoethane and H2O. Now children, you will see that ethanol reacts with hydrogen iodide. I have written reflux over here. So what is reflux? Refluxing is a process of heating a liquid in a flask provided with a condenser. The vapors of the liquid which rise up get condensed back into the flask. Students, this is the next method of preparation. I have used phosphorus halides. See the first reaction. Ethanol reacts with phosphorus pentachloride to form chloroethane plus POCl3 plus H2O. In the second reaction, I have used a secondary alcohol. You remember secondary alcohol, 2 degree alcohol. So I have used propan-2-ol. It reacts with phosphorus trichloride to form 2-chloropropane and H3PO3. Children, I want to tell you one thing. Whenever you write down a reaction in organic chemistry, don't forget to write down the names of the reactants and the products. Now, I am not asking you to write down the names of all the reactants. The vital reactant, for example, in the first reaction, the vital reactant is ethanol. So I have mentioned, okay. In the second reaction, the vital reactant is propan-2-ol, so I have mentioned it. Similarly, in the products side, the vital products are mentioned with their names. I hope you can understand which one is vital and which one is not that important. Children, when you are writing down the reaction, you have to write the reaction fully balanced and you have to name the reactants and the products of the vital components. Alright students, now I have used thionyl chloride. Yes, thionyl chloride I have used. Thionyl chloride reacts with ethanol in the presence of pyridine to form chloroethane, sulfur dioxide and HCl. I repeat once again, ethanol, which is a 1-degree alcohol, reacts with thionyl chloride in the presence of pyridine to form chloroethane and SO2 and HCl. Now what is the function of thionyl chloride over here? Children, let me tell you one thing. This method of preparation is preferred than other methods because both the products of the reaction SO2 and HCl are gases and can easily escape, leaving behind pure alkyl halide. Therefore, the chloro compounds can be purified easily. Students, I am going to discuss the next method of preparation of haloalkanes. Pay attention. If we sum it up, what will happen? This gets cut, this gets cut, this gets cut. So CH4 plus 4Cl2 gives CCl4